I'm Greg Misicko, and my final project is on Amazon Kinesis. Amazon Kinesis is essentially a messaging service like SQS, but it specializes in serving massive amounts of data with very high reliability. You'd use Kinesis instead of SQS if you needed to be able to reorder records in the same order they were received in, if you needed to consume them multiple times using various consumers, and you required them to be highly available and near real time. A standard Kinesis flow has producers putting data onto one or more data streams, with consumers taking that data and processing it or storing it for some useful purpose in the back end. The data streams are made up of one or more shards, where a shard is a fixed throughput unit used for carrying data. Those shards are replicated over 3 availability zones to ensure your data doesn't get lost and is available for a period of 24 hours. Amazon implies that these consumers should be in the Amazon cloud, but really could be set anywhere. And in my demo, I'm actually running everything from the consumer side locally. Amazon provides a few nice demos to introduce you to Kinesis in action, one of which demonstrates real-time clickstream data being presented in a JavaScript graph. This is a good one to start with because it's set up as a CloudFormation template that anybody can run. Just go into the AWS console, look it up, run it, and you'll see the data streaming on the graph. They also have access to all the source code in there, so if you wanted to modify it and do something similar in real life, you'd be able to do that. Another demo is the log4j appender for Kinesis, which feeds log information through Kinesis into a MapReduce cluster, where you can then perform Hive queries on the data. This demo requires manual setup, but the instructions are very clear, and it wasn't difficult to get up and running. My demo focuses on the key building blocks of a Kinesis project, starting with creating a stream, then putting data on the stream, viewing the details of your stream, such as how many shards it contains, and observing the throughput, getting data off the stream, and some of the essential management operations, such as splitting hot shards or merging adjacent shards. With these building blocks, the only thing left in a Kinesis project would be to determine what you want to do with your data on the consumer side. Now, I'll walk through my code at a high level, but to really see what it's doing, I'd recommend downloading the source from GitHub, which I give the URL to at the very end of this presentation, and play with the main class, which just sets up streams, pushes through some simple data, consumes it, and then performs some basic operations. And there's not much to visualize with it, but there are console outputs that'll give you the status of what's occurring behind the scenes. So starting with creating a stream, the first thing you want to consider is how many shards you'll need to support the data that you have coming in from your producers. Each shard can handle 1,000 put records per second, up to 1 megabyte of data per second, and 2 megabytes per second of data output. So how many shards you'll need can be calculated pretty easily by determining how much data you think you need to support on the upstream versus the downstream, and then providing enough capacity for the larger of the two. You don't want to overdo it because you get billed per shard, and I'll talk a little bit more about the cost in a moment. But once you've determined how many shards you need, the only thing you need to do is choose a name for your stream, and that's about it from the code perspective. Once I submit the request for a stream to be created, you'll need to wait for a few moments before it becomes active. So before I start pushing data, I set up a little loop that watches the status of the stream, and I wait for it to show as active. Usually it takes around a half a minute for the stream to become available. And I apologize again that I don't have anything flashy and cool to show from running a Kinesis demo, but there isn't a lot to visualize in the middle tier except for the console output statements. So in the case of creating a stream, all you'll see is a confirmation in the console that a stream was created successfully, or most likely if you get an error, it'll be due to the stream name you selected already being in use. To take inventory of your streams, you can pull a list from AWS, but one thing to understand is that AWS will return results to you in chunks. So you need to make sure that when you're fetching your list of streams, you keep going until you've received them all. Otherwise, you may be looking at an incomplete list. It's very important to delete your unused streams when you're finished because there are no free tier options for Kinesis. These powerful, reliable data streams come at a price. And even though we're only looking at a few cents per hour on the low end, this could easily add up to $10 to $15 per month if you leave a stream lying around. So fortunately, deleting a stream is very simple. You just need to know the stream name. And of course, you could always view your streams from an AWS console and easily delete them from there. Now, the producer is the application that you want to be collecting the data from. In the Amazon demo for the clickstream dashboard, they were just randomly choosing from about 6 URLs and counting how many times each URL was randomly selected. But in the real world, from your application, you'd be recording information that really matters to you, like the log file entries that was simulated in the other Amazon demo. The producer obviously has to have some data object it wants to send into the Kinesis stream, and you'll always be sending that as raw bytes. You'll also want to specify a partition key for this data. Now, the partition key is used to categorize your data, and it's up to you to determine how or if you want to do that. What you need to know about the partition keys is that once a partition key is used on a shard, all future put requests with the same partition key will be sent to the same shard. And this helps you on the consumer side, so you don't have to search across multiple shards looking for your categorized data. If you don't care about categorizing your data, then don't worry about what you set for a partition key. It could be the same thing every time. It could be a random number. It's up to you. And again, Kinesis demo doesn't provide much to look at, but looking at the data being sent to my stream, you can verify that the partition keys are always hitting the same shard. It's just a small sample of data, but if we had 100,000 records here, you would see that session 4 partition key would always land on shard ID 4. Session 3 is always going to land on 3. Session 1 always lands on 3 also. And that continues to be the case forever until that shard is closed or the stream is deleted. On the other end of the stream, from the producer, we have the consumer. And the consumer is responsible for picking up the data and doing something with it. It could be feeding data into a real-time dashboard. It could be writing the data to flat files. It could be loading it into a search engine or a database of some sort. It all depends on what you need to do with it for your particular use case. To start pulling records off of the shard, you'll need to create an iterator. There are 4 types depending on where you want to start taking the records from. You start at a specific sequence number. You can start right after a specific sequence number. You can start from the very first record available, which is called the trim horizon. And remember that data older than 24 hours is constantly being pushed out forever. And then finally, there's latest, which gets all incoming data from this point in time forward. You can also set a limit on the number of records to pull in per request. And if you don't do that, by default, you'll get up to 10 megabytes per call. Once you've set up your iterator, you can start pulling records and doing something with them. For my demo, I've removed the endless loop because I just want to verify that we did in fact put and get data successfully. But normally you'd leave this consumer alive and running endlessly. Also, I don't do any serious data processing here. I just return the records so that they can be verified. It's not that I didn't want to do something bigger here, but that work really goes outside of the scope of Kinesis. Then it turns into an EMR project or something else. So remember that your data is encoded when you put it up on the stream, and you'll need to know how to decode it in the consumer. In my simple case here, I just cast the data back to a string, and I print it out so we can verify that what we put in is what we are getting out. When we created our stream in the beginning, we estimated how much throughput we'd need to be able to support. But obviously over time we could discover our estimates were wrong, or we could find that loads are increasing or decreasing and we want to add or remove shards. You can monitor your shards easily from the console, or you can programmatically grab this information using the CloudWatch APIs. And you can see in this graph that I'm not coming anywhere close to using the capacity of the 2 shards I've set up. The threshold is indicated by the red bar on the top, and my usage is marked by the blue line on the very bottom. So I'd probably be better off if I reduced from 2 shards down to 1. When you reduce or expand your streams, it's called resharding. And to reduce your number of shards, you do it through a merge. Merging is a pairwise operation, and the 2 shards must be adjacent, which means their hash key ranges, which are based on the partition keys they hold, must be contiguous. If you've confirmed that your 2 shards are next to each other, and in my case I only had 2 to begin with, then you send those two shard IDs into the merge request. Common exceptions here would be if one of the shards you identified doesn't actually exist, or if one of the shards is already closed. Splitting a shard just takes one shard and turns it into two, essentially. The thing you have to decide here is how you want to divide the partition keys stored on the shard. You could move one very busy partition onto its own separate shard, or you could evenly divide the partitions across your two new streams. And in my case, for my demo, I just split my partition keys into two equal sets. When you merge two shards, you might have expected to see one single shard in your stream list afterward, or if you split a shard, you might have expected to see two shards in the stream list. In my demo, I started with two shards, I merged them into one, and then I split that one shard back into two. And in the end, that leaves me with a total of 5 shards in my stream. And why is that? It's because even though you're adding or removing shards from your stream, you don't want to disrupt the consumers who may still be processing the data from those shards. So those shards are going to remain available until 24 hours passes on the most recent data record added to the shard. So this means there shouldn't be any disruption to the consumers that you have working on the data. They'll continue doing their work until the data runs out, and you'll have consumers working from the newly opened shards at the same time. A closed shard continues to be consumed from, but it can't receive new records, and it can never be split or merged again. To run the actual code I was discussing here, you can find it available on GitHub at this URL. It shouldn't require any modifications, assuming you have the AWS SDK and your AWS credentials file is in the default location. The demo will create a stream, and it'll run through the operations I discussed here, and you'll get a console printout of the operations every step of the way. It's probably confusing at first, but play with the main method step by step, and hopefully it'll start to make sense what each part is doing. I've also hosted a document that provides a more detailed explanation of the code at this link to Google Docs.